Alrighty, so like Cole briefly said, I'm going to be talking to you guys about security in software development today. I know it's the most exciting topic in the world, but bear with me, it's important. So, who I am. My name is Logan. What do? I work for an insurance company in Des Moines doing software development, and I work for the IASG Research Lab doing many things which include software development. So, an important note before we get started, this talk is non-exhaustive for the simple reason of software development is a massive, complex, and scary field on its own. When you try to make things secure as well, it gets even scarier. It would take essentially infinite time to go over every possible bug, every possible vulnerability. I don't have that kind of time, you don't have that kind of time. So what we're going to do today is kind of go over some common examples of things that introduce security holes in software development, how to remediate them, and we'll go over a couple of examples. One is an example of some code that I had the pleasure of code reviewing, and one is an example of some code that I actually wrote. So what is security in terms of software development? So if you just go look up security and software development on Wikipedia, you get this wonderful explanation. Security as part of the software development process is an ongoing process involving people and practices and ensures application confidentiality, integrity, and availability. Secure software is the result of security-aware software development processes where security is built in and thus software is developed with security in mind. That's really long, really complex. It really boils down to the practice of writing perfect code free of exploitable bugs and mechanics. What does this mean? Software can be kind of big and kind of scary. And the bigger and scarier it gets, the more potential you have for bugs. Bugs are the basis for exploits, because an exploit is just taking a misbehaving chunk of code and getting it to do something unintended that values the attacker. So obviously, to remediate this, you just never write bugs. Write perfect code always. That's not feasible, but that's the goal here, right? So, why is that hard? First and foremost, here is the development cycle of an application, especially in the past. It's kind of changing now as security exploits are getting more and more prevalent and significant. But the traditional flow of an application would be a rough proof of concept with minimal functionality, a test app that mostly works, a release candidate that's almost ready for release, and then your released production app. So at this point you've got users touching it and it's out on the public internet and it's being interacted with. And then it gets exploited and then security gets added. The problem with this is obviously, since security is being added after the exploit, the damage has been done. Ideally, you'd want to move security to the first thing. So when you're planning out your app, before you even start writing code, you start planning in your security. Unfortunately, that's not how it often works, because that's hard, and business majors don't like it. Beyond that, developers are lazy. Yes, all of them. Yes, that includes you. Yes, that includes me. Writing secure code it's challenging. It takes a lot more time. It's a lot easier to just write a SQL query in the form of a string and then just plus sign some user input in the middle. But if you've ever done SQL injection, you'll know that that's a bad idea. Come on. So, on the topic of injection, although this is not SQL injection, example number one. This is some code that a coworker of mine wrote, slightly modified because I can't show you the exact code. A little bit of context of what this did. This takes a pull request ID and a get branch name from a user via a web app and runs a shell script which does magic on this get branch and this pull request, right? This was a JavaScript application, so can anyone here just real quick see what the problem is?
It's not being sanitized.
It is not being sanitized. If you look right up there, that first line, right? Or second line, var cp equals spawn path to shell script ID branch. What's happening there is a shell script is being arbitrarily called with 2 parameters that are passed from the user. A fun little exploit for this that I actually used to show him how bad this was passing in a branch name so it did the thing and wall hi, just to say hi to him, right? So his solution, you can see it's there in the slightly darker text. If the branch name includes a space, because Git branches can't include spaces, or the type of the ID is not a string, I don't know why, it should be an int, callback, which is JavaScript for return, invalid arguments, and false. Who can see the problem with this? No? Okay. Well, what?
You should be able to do the same thing. And, just without spaces.
Yes, TM. However, I got a little fancier when I exploited this one. So I'm still passing in the branch name and ending, so it does the thing it's supposed to. But you'll see the second bit there, CMD equals $ quote escaped 20 etc password and cat $CMD. If you're not familiar, the escaped 20 there is a space. So that's how I got past his rudimentary space sanitization. And first we set a variable to command, and then we cat command, which essentially was catting etc password. Don't do this. Why did you do that again? Okay. So the proper remediation for this one, never, ever, ever, ever take input from a user and don't sanitize the crap out of it. Be as strict as humanly possible when you're doing your sanitization. In this case, you can see there's a regex string right down below there that would allow only the characters A through Z, 0 through 9, a /, an underscore, or a dot, case insensitive and globally. Because these are the characters that are allowable in a Git branch name, right? Rather than just checking, is there a space, we should be limiting it to only the characters which are allowed. Now, ideally, we might want to go through and make sure that we're not doing anything fun with using that dot as an escape character for the regex later, but this would be a whole lot better than just saying, does your branch name have a space in it? So this is kind of the end of the first example here, which is just injection from users, right? This was command injection. This can also take form of SQL injection, pretty common. But as it says, never trust a user's input without sanitization. So the next pitfall in development is because developers are lazy, they like easy things. Dependencies are easy, packages are easy. npm install, pip install, yum, Ruby, gem, whatever your favorite package manager is, installing packages is a whole lot easier than rewriting functionality yourself. There are 2 bullet points here. The first one is a fun little dependency that I wrote that I shipped for NCDC. Pretty harmless, it just crashes your web app if you put it behind a firewall. Not very real world, but a fun little example. The second one is a very, very bad one. So what happened in the second example here is there is a library in the Node.js framework, Node.js being a JavaScript server-side, single-threaded asynchronous web server, which is very, very popular at the moment. It's kind of the hot thing to move your web apps to. So there was, deep inside of the Node core library, there was a dependency. And this dependency was written by a developer a couple years ago, and he was no longer maintaining it. He was no longer using it. It worked, and it was just a requirement of the core library, which meant that every web server out there was using it. A user on GitHub made an issue and said, hey, I think this would really be a whole lot better if we included Flatpak support, which is JavaScript nonsense that you don't need to worry about. So the author said, yeah, I will approve that merge request if you go ahead and code it in. A different user, I forget his username, Chinese gentleman, messaged an original developer and said, hey, will you accept a merge request if I write it? And he said, sure. So he went out and he wrote a Flatpak implementation for this particular library. And it worked, and so it got merged in. However, the original developer didn't want to deal with any of it. So he just gave complete publishing rights, ownership of the Git repo, everything to this new guy. The problem with that was he no longer had access to fix it when it came out that it was backdoored by this wonderful developer. The backdoor in question targeted a specific form of Bitcoin wallet, and it basically meant that every browser that had updated their packages to that version or newer was vulnerable to attacking Bitcoin wallets. So there's a link there to SNCC. They did a really, really good write-up on what happened, a really good step through by through. But for a little while, a couple weeks, every node web server was trying to steal your Bitcoin. And it could have been a lot worse. It could have been stealing credit card information or what have you, but this guy wanted Bitcoin. So this was, I believe, before the crypto bubble burst, so Bitcoin was still worth a lot of money. So the moral here is look at your dependencies. Don't just npm install the first thing that looks like it'll do the job. Read what it is, make sure you know what you're doing, and be paranoid. So the next big thing, and honestly the biggest thing, is that people make mistakes. There's a quote there by Tom Gilb. I had no idea who it is. I just saw this quote a while back and really liked it. At the source of every error which is blamed on the computer, you will find at least 2 human errors, one of which is blaming the error on the computer. People make mistakes in a lot of different forms. Some of the really common ones down there are just typos, which lead to bugs, using methods without knowing what they're doing, or using different packages or dependencies. And we'll touch on that one in a second here. And not considering all edge cases. So like in the first example, not checking out and thinking what happens if the user passes and cat Etsy shadow, right? Unfortunately, every computer program, as much as we like to blame issues on the computers, was written by a human, and humans suck. We screw up all the time. It's part of being human. So example number 2. This is an example of some code I wrote, actually the new CDC sign-up application. A couple of members here, looking at you, Losby and Cole, are actually aware of what this particular bug that's on the screen did. So for a little bit of context, this class definition is the definition of a view-based class, which is a Django way of routing HTTP requests and such. That you can see the comment about what this method does. And down below you can see the URL spec that tells Django how to route the packets so that it was getting to this method, right? So can anyone here take a look at this and tell me why it didn't work? For even more context, base view is the Django view. It's the default class you extend to route packets. Login required mixin is a chunk of code that just makes sure that the user is logged in, and user is captain mixin is a chunk of code that makes sure that the user attempting to access this route is a captain. I can guarantee you that all 3 of these do work. So tell me why this doesn't. Nick.
You need a team one. If someone is a captain and logged in, they can just move people, but that doesn't necessarily mean it's for their team.
That is not the issue in question. That would be an issue, except for that's handled further down in the code that you can't see because I didn't have slide space to put the whole method up there. Any other guesses? All right, well, Now we're going to talk about what to do when it all goes wrong. Don't worry, we'll come back to that. We'll explain what was wrong with that method in a minute. So I start getting some reports of abuse almost exactly a week ago at 5:08, just before the last IASG meeting, where I hear that URL injection is a thing. So what was happening is the two aforementioned gentlemen sitting up front here discovered that if you just started throwing random team IDs at the end of that path that was on the screen earlier, you could add or remove random people from teams, or just add everyone to your team. So that's not good. So at this point, I was not here. I was at home doing exams and quizzes and stuff because midterms. But at this point, I got out my laptop and started writing a fix for this, trying to figure out why it was happening. So then I get a message from a friend named Matthew Burkett, former IASG member. So on the left there, you can see what he slacked me, which is a PGP encrypted message, which if you're going to report a super critical vulnerability is the right way to do it. My GPG key fingerprint is down at the bottom in case you find such a thing and want to report it to me. But if we look on here, you can see that I decrypt the key. You can see that it was encrypted by Burkett, and it's to me. And the message is, non-authenticated users can see signup.ish.org/admin. For those of you who aren't aware, /admin is it's where all of the important stuff lives. I don't believe anyone except Burkett found that based on my logs. But anyone could have just gone to /admin and done as they pleased. Changed settings about the competition, seen competitor info, dumped emails. Yeah, this is considerably not good. This is very, very bad. So, oh yeah, there's the code for admin dash, the page that lets you see /admin. Can anyone see why this is wrong? We'll go over it in a second. Okay, so the reason that I'm including this part in, not in the first bit, which is why is security hard, but in what to do when it goes wrong, is because at this point, I had to make a decision here. So if you get a vulnerability disclosure, like I did from Nate and from Burkett, you kind of have a couple options as far as how you're going to fix it, right? The first option, which is what you want to go with if it's pretty low security, not that big of a deal, is just fix it in the next development cycle, right? So at a traditional company, a lot of companies are doing agile now, so they'll have, say, 2-week sprints with 4-week epics or something, and so they'll be doing a new version every 4 weeks or 8 weeks or whatever. A low security thing you'd want to fix in your next development cycle. That's if it's, you know, maybe it occasionally crashes the app, but no data is being leaked, nothing bad is happening. The second one, which is what I was doing when I found out that URLs could be injected, is start writing a hotfix, but don't interrupt service. So what you're doing here is you are trying to write a fix for the bug as soon as possible, but without interrupting service. This is for things that are a little more important, but stopping shy of, say, leaking personal information, credit cards, or you know, anything like that. The most severe is you disable the service and you start working on a hotfix immediately. This is for when you are leaking sensitive information, when users are able to do admin-y things that they shouldn't be able to. So when I got the message from Burkett that /admin was accessible, this is what I did. There was probably about 10 minutes where sign up was just offline. Now, why was it only 10 minutes? Well, if we go back here, the reason that these views were insecure is human error. I did not go and thoroughly read the class-based view documentation because it's very, very long and boring. The crux of it is, I'm passing in three things, right? The template view, which is what you extend to render HTML pages and handle posts, gets, etc. Login required, which we already talked about, and user is admin, which just checks to make sure that the user is an administrator account, in this case, a member of the white team. What I did not know when I wrote this code, and I have since learned, is that this is the appropriate order. The difference here is that base template view and base view have been flipped to the end. Because for any of you writing Django in the future, class-based views take this list of arguments and go start at the first and work their way to the end until they get an HTTP response returned. Which in this case means that it was going and hitting base view or base template view, which was returning an HTTP response and going home. What it's doing now is saying, is the user logged in? Does the user have the right role? And then we're going to handle that request. This whole fix, there were probably about half of the routes in the application were messed up like this. The whole fix, once I figured out what it was, took me about 3 minutes to fix. Took me an additional 10 or 15 to figure out what it was. Fortunately, like I said, nothing bad happened. But this is, the worst that happened, I should say, is that Cole and Nick traded team members a couple times. They figured out how to steal team members from each other and just traded back and forth. But this is a really good example of how, no matter what, it's entirely possible to make mistakes when you're writing code. And that security is really hard, and you're gonna screw up. And it's important when you screw up to deal with it properly, but it's also important that you try and make sure that it just doesn't happen in the first place. So, some takeaways here. Introduce security early and introduce it often. Make sure you're thinking about it from the start of your development process all the way to the end. Don't just tack it on at the end once something gets broken. Don't just tack it on once the regulatory committee says you should. Do it early, do it often. It'll save you a lot of time later because it's a lot easier to implement it up front than it is to go back and implement it when you're done. Even though it's a little more effort than just not implementing it at first, it's worth it in the long run. Second, RTFM, or know what that method and package does in its entirety before you start using it. This would have saved me my problems. It would also save people from downloading vulnerable dependencies that promise to do one thing and do others. Audit your code. Run different automated code checkers on it. Read through it a couple of times, make sure it's not doing something stupid. Ideally, have someone else look at your code too. Make sure that before you commit to master and push it to production that you get a second pair of eyes on it, because I didn't catch that bug. The guy who wrote the first chunk of code that we looked at, he didn't catch that bug. And ideally, have several people look at it. I know that at least at the internship I have right now, the process is I write code, I commit it, it gets an initial review before it gets merged into a release build, and then every month or two at the end of that epic, the release build gets a full audit by a couple of people before it gets merged into master and pushed to prod. You want to make sure that you're reviewing your code often and that it's not going straight to master. Don't commit straight to master. In fact, if you're more of an admin perspective than a developer perspective for a second, maybe consider making it so only like 2 or 3 people in the entire organization can commit to master, because why? The second one, use automated tools. There's a list right there that OWASP has of a lot of code scanners. Some of them do more security-focused things. Some of them are more about quality. The 2 that I used are SonarQube and Sonar Cloud, which is a static code analysis tool. That one does some security and a lot of just like code tidying and are you being dumb. And then SNCT, which is more of a security-focused one. Both of those are completely free for open source projects and have non-free versions for non-open source projects. But that list there is a really good list. It has, I want to say, like 30 different tools on it, most of which are free. Use them. Make sure that you're not doing stupid things. And it never hurts to, if you're going to install open source code, run someone else's open source code through those tools if it's not already being done before you start using it. And then last but not least, have a fallout plan, because you will screw up eventually. Someone will screw up, something will go wrong, so everything will catch fire. Have a plan for what you're going to do when it does. You hope it never does, but sometimes we have Equifax situations and literally everything is on literal fire. And we don't like that. So have a plan, know what you're going to do if it does happen, and just pray that it doesn't. And that is, oh, hello, wrong button. That is kind of the end of what I have prepared. If you have any questions, now is the time to ask. Okay, well, I guess I didn't quite fill my 45-minute slot, but I will hand this microphone off to Cole then. Thank you all for listening to me talk for a while.